Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. Now, we haven't spent a lot of time talking about variable scope. It's actually extremely important. We recently learned that it also impacts the lifetime of objects, so we want to spend a little bit more time really making sure we understand the scope of the variables, whether they be variables holding simple types or references to complex types in our applications. And not only do I want to fully explain that, but then I want to use that as a launching pad to explain keywords like public and private that we've seen several times in our course up to this point, but I haven't really talked about. Before we talk about that, let's talk about variable scope. So let me start by saying that whenever you declare a variable inside of a block of code, that variable is only alive for the life of that code block and any of its code blocks, any of the interior code blocks or code blocks inside of that code block. Meaning that when the code block is finished executing, the variable that was defined inside of that code block is no longer accessible and its values are disposed of by the .NET Framework runtime. So we'll start by looking at how that is impacted by common code blocks that we've been working with up to this point, and then we'll use that and expand beyond there. So you can see that I've created a project called Understanding Scope, and you can pause the video and catch up with me. I want to create this project and focus on testing how variable scope works, and so I'll start with a pretty simple code example. Again, the concepts that we talk about also apply to object references, not just variables that hold simple strings and integers. All right, so let's start by creating a simple for iteration statement, and we'll just loop through 10 times, and we'll do a console.writeLine containing the value of I, and then here we'll do console.readLine so we can see our results, and we'll run the application. And as we would expect, we can see values from 0 through 9. Now, what if I wanted to access the value of I here right after the closing curly brace for the for statement? We'll notice that I'll get a red squiggly line under I, and if I hover my mouse cursor over it, it says that I does not exist in the current context. Why? Because I is now outside of the scope of its definition. We defined I inside of the for loop. It's available inside the for statement itself plus in the code block below it, but not outside of either of those. All right, so we'll have to comment that out. So second, let's start, we'll continue by going and creating a string of j equals empty string. And what we'll do inside of our loop here is just go j equals I.toString. Now, let's go outside of our loop. Will we be able to access the value of j? So let's go outside of the for, and will we be able to actually print to screen the value of j? All right, we are not getting any errors, so let's run the application. And you can see that the last value that was inserted into j was the value 9. Since we defined j outside of the scope of this code block, of the for statement and its code block, we can access it inside of that code block and outside of that code block as well. All right. Next up, let's look at at something like this, where we'll actually create what's called a field or a private field. So we'll go private static string k equals, and a private field is sort of like a property, except it's private in nature, but it is available to all of the members of the class. So we should be able to see k inside of our for loop. So let's do I.toString. We should be able to see it here as well in the outside of the for loop, like so. Let's go ahead and run the application. And you can see that second console.write line will also display the number 9. But the real question is, what if we were to create a helper method, static void, and we'll just call this helper method. And here we'll go console.write line, and we'll say this is the value of k from the helper method, and we'll do that. Now here we'll call the helper method like so. Will this work? Well, we'll be able to access the value of k as it was set inside of our for loop outside of our static void main. Let's run the application, and you can see that we can in fact get the value of k from the helper method. Why? Because k was defined at, I guess you could say, the class level. It is a sibling to static void main and static void helper method. Therefore, it's accessible to each of these as well as any of their inner code blocks. All right, hopefully this is starting to make sense. Let's go inside of the for loop now, and here what we'll do is a simple if statement. So if I is equal to 9, so on the very last run of this, then let's declare a string called L, and we'll set that to string, the I to string, and then outside of that we'll go console.writeLine the value of L, and as you might anticipate, we will see that L does not exist in the current context. Why? Because we declared the value of the string variable L inside of the if statement's curly braces. Outside of those curly braces, it's no longer accessible, so we have to comment that out. All right? So hopefully this solidified in your mind many of the combinations that we can use in determining whether something's in scope or out of scope. And if you had any confusion about this, hopefully that cleared it up a little bit. All right, so now let's move on to the larger topic of accessibility modifiers. We've been creating classes, specifically the car class up to this point, and whenever we were creating methods, I would typically use the public keyword. Occasionally I would use the keyword private like I did here in line number 11. Private and public are both accessibility modifiers. They're used to implement a tentative object-oriented programming called encapsulation, which is actually pretty important. So in a nutshell, you should think of classes as black boxes. And whenever you think of a black box, maybe you can think of like one of those old style television sets. Maybe your parents or grandparents had one. I remember as a kid us having one. There were no remote controls. You had to get up, walk across the room, and actually turn the dials of the TV in order to tune to either VHF or UHF channels. You had another volume maybe or a dial where you would adjust the volume. You had an antenna in the back, so you would connect this wire out to your antenna, and you had another one where you would plug it into the wall. And everything else about the television was self-contained. Now, as a kid, I was fascinated whenever my dad would pop off the back of the television set, and he'd go and try to fix it by changing out the tubes. And it's always seemed like magic to me because I knew absolutely nothing about the innards of televisions. All I knew were the public interfaces, the button for on-off, the dials to turn the channel, the dial to turn the volume up and down, the antenna, whatever that did, and the little plug that would obviously give it electricity. But frankly, in order to use the television set, that's all you really needed to know, right? You did not have to know anything about how a television worked. All you really needed to know was how to plug it in and change channels, turn it on and off, and then adjust its volume. And that is exactly how your classes should be treated. All the important behind-the-scenes functionality should be encapsulated behind interfaces like public methods and public properties. Now, classes might, in fact, have private fields like we looked at here in line number 11, or they might have private methods that are used behind the scenes to enable all the magic that goes on inside of that class, but the consumer of the class shouldn't know anything about the inner workings of the class in order to work with the class, to operate the class. All they need to know is what's publicly exposed through the public properties and public methods. So in a nutshell, private means that a method can be called by any other method inside of the same class. So I've used the term private helper method a number of times accidentally. Essentially, when I use the term private helper method, I'm talking about a private method that adds some additional functionality to those public methods that are exposed to anybody who needs to work with the class through that method. A public method is what's actually going to be then called by somebody outside of the class, some other code outside of the given class. And private methods are only going to be called by members inside of the class. Okay, so let me do this. I'm going to paste in some code to recreate our car class. And here I have a public and a private method. The public method is called do something, and the private method is called just helper method. All right, and these are not very interesting examples. I want to keep this as simple as possible. Now, from the outside of this car class, let's just kind of roll this whole thing up here and save it. And now whenever I want to go here inside of my static void main, I might want to work with the car class. So I'll go car, my car equals new car. And then I'll do my car dot, and notice that I can only see the public method do something. Now, I might happen to know there are other methods also inside this class, but I can't see them from outside. Their visibility is hidden to me because they're marked as private. All I really need to know is how to use the do something method, and if I understand that I can call that, all the implementation details will be hidden from me, but it'll work as I expect it to work. Here you can see that it merely prints out the words hello world. All right. Now, how it does that, whose responsibility inside of the class it is to actually display that, that's none of my concern. All I need to know is how to call the public method do something. Okay. So in a sense, the consumer of the car class has absolutely no idea that that helper method even exists. All it really knows is that there's one public method, and it could call that public method, but it doesn't know any of the hairy implementation details, right? Now, I use the term in a sense, that in a sense the consumer of the car, the consumer is going to be a software developer, and a software developer is going to be able to drill in and say, oh, I see how it's doing its work. It's actually making a call out to this other private helper method. And so, you know, there is a sense in which it is public to developers, but it's private from the perspective of the consumer, which is this main method. It can only see the do something method, not the private helper method. Okay, that's all we really mean here. Now, admittedly, this is extremely mundane. It's a simple example that's only real value is to illustrate the notion of encapsulation, that we typically want to hide the implementation of our classes behind well-known public interfaces, in this case, a friendly method called do something. And the purpose of this lesson is to better understand the notion of scope, because we said that once variables, especially variables that contain object references, fall out of scope, their objects will be garbage collected. Furthermore, it's important to understand that there are parts of classes that you have access to and parts of classes that you don't have access to. Now, if you ever decide that you want to create your own custom classes someday, even a library of classes that represent the business domain of your company or of your specific application, it could be a game, you should strive to expose public methods and give a simple, straightforward, obvious way to call the public methods from your class, but keep all the other helper method, all the other internals privately tucked away and not available to prying eyes. So you don't want a developer to simply go fiddling around inside of all of your methods and use your class in a way in which it was unintended. You want to give them a way to use your class properly through the methods that you've designed and that you've made available through public interfaces. And this also will help to remove any ambiguity in the usage of your classes, and it should be much cleaner as well. All of these things were under consideration whenever the developers built the .NET Framework class library. In the .NET Framework class library, methods and properties are exposed using the public keyword. Now, they might also be using private fields and private methods behind the scenes, but you would never know. They may use other types of accessibility modifiers as well. There's actually a couple available called protected and internal. However, these are primarily for whenever you're working either in a rich inheritance relationship between classes and you're building a rich inheritance hierarchy between classes, or whenever you're working with a very large library that's compiled into separate assemblies. That's when some of these other accessibility modifiers might come into play. They're topics that are beyond the scope of this absolute beginner series, but topics that I do cover on Developer University. So if you want to know more about object-oriented programming and encapsulation, by all means, go ahead and... All right, we are well past halfway through this course. You're doing great. We've already covered the most difficult material already. Now we're just adding on details. So you should be encouraged by that you're still plugging away at this. And you're doing great. We'll see you in the next lesson. Thank you.